We're talking about when you go to a service call and you diagnose a failed compressor and the process of diagnosis surrounding that, right? So it's we're quoting a lot of compressors. We're seeing a lot of compressors quoted and not a lot of other like notes about the system or quotes related to the rest of the system. Compressors generally are made pretty hardy. It takes a lot to break them, is what I'm saying. It takes a lot to actually break down a compressor. A lot of time, heat, acid, or electrical issues to cause a compressor to fail. So when we have a failed compressor, what should we be asking ourselves?
What killed this compressor?
What killed this compressor?
Who did it?
And then 3 question marks. You got to make sure you ask those.
3 question marks.
Yeah.
Got to be like, what in the
Killed
world?
this compressor?
How is this possible? Acid. Okay. Acid is one of the #1 compressor killers out there, compressor killers. It is also the #1 cause for the second compressor death. So you replace a compressor and the second one dies, the #1 cause is acid. Anybody know what causes acid in a system?
Water.
Moisture? Yeah. Anybody else? Anything else? Yeah, moisture. Okay, I'm hearing a lot of moisture. So moisture causes it because like 410A refrigerant, you have the POE oil, the polyester oil. So moisture in the system interacts with the oil and it becomes a form of acid. And then that breaks down your compressor's ability to over time it breaks down the compressor's ability to the oil's ability to lubricate the compressor and keep it running smooth and clean. So yeah, moisture is a big one.
That same moisture and acid also cause or help contribute to those aluminum coil leaks.
Yeah, so it can break down aluminum coils as well. Yeah,
Pull
that's
it
true.
vacuum.
Yeah. So let's get all the moisture out. But what I want to focus on today is when you show up and you're diagnosing a compressor, we need to be taking steps there to address the whole problem, right? We're not just quoting a compressor. When you diagnose a compressor, it's kind of it's a fun sort of like diagnostic hit often. It's a big failure. You've just proved something. You've shown that you're a technician. You got to win. Maybe this is going to turn into a system sales. That's exciting, but we need to slow down right there and answer this question and run through whatever we can to figure out what killed this compressor. So another thing that causes acid is high heat inside the compressor. So your oil, your compressor oil, will deteriorate with high heat. So if you have some scenario creating really high temperatures, like impacted clogged condenser coils, I mean it's running at a really high temperature, it can break down the oil over time. Or when you have a burnout, like a compressor burnout, where electrically there's a burnout in the compressor, that really high heat moment in there can actually cause your oil to deteriorate. You got the oil in the system that actually needs to be removed because it's going to be an acid at this point. It's going to cause damage to your next compressor. Okay, so what do we do if a system has acid? Or how do we know? Let's start with there. How do we know if a system has acid?
Acid test.
Yeah, we have different kinds of acid test kits either on our van or here available at the
You
shop.
said different kinds,
We do. There are a couple different kinds out there.
but they all do the same thing.
They test for acid. Well,
It's not like there's different kinds of acid we're testing for.
no,
There's just
not.
different formats.
Yeah,
to test.
I'm sure there are different kinds of acid you could test for, but with what we're working with, 410A refrigerant, pretty much exclusively, yeah. So what are some other clues that you have acid in the system? You guys have experienced this.
Smell.
It's taste.
It's smell. We'll go with smell. We're going to focus on smell. Yeah, often you can you're taking off your hoses and that smell of acid is like that burning, Ouch. How do we fix an acid problem?
Replace the
Cover the
compressor,
refrigerant.
the accumulator.
Line dryer.
Accumulator,
Suction
compressor,
Suction line dryer.
suction line dryer. Yep, it requires a second
Flush.
trip, acid flush, acid away, some sort of acid treatment. And so when you are diagnosing a compressor, that's kind of important to know before you're sending a quote, right? What we will often do is replace the accumulator because that's where oil will gather in the bottom of an accumulator, right? And so you can't always get all of that out. If you're worried about acid in the system, it's best to quote just replacing the whole accumulator. Whereas on a normal compressor replacement, you can typically take that and dump the oil out, but you're never going to get it all out. If there's acid in there, just quote to replace the accumulator. And then what's up?
Do you worry about indoor components too? Like does the TXV get damaged or anything like that? Or
No, like Ronnie said, you can contribute to coil breakdown. So if you have an aluminum coil, like you need to be thinking about leaks.
So
Which will
my
be our
suggestion
next.
would be is if you had like acid compressor failure, and maybe it's like the original coil on mid-aged Linux, like 8-year-old Linux, you pretty much guarantee that if you do a out of warranty $3,700 compressor there, and you know the system has acid, well, that coil's probably not too
Yeah.
far away.
gotcha.
Yeah.
So you kind of want to keep that in mind if you're going to be quoting large repairs like that. Like, yeah, the system does have acid. You could see it could, coil failure in 3 months and then hate our guts.
Right.
Would you do it the other way too? Like if you found a leak in a coil because you were low, would you do an acid test just like out of hand to see if it?
I guess if you have one, it never hurts to do an acid test.
Yeah, but typically you're gonna, if it's through the whole refrigerant system like that, you're gonna smell it typically. And that's another point on burnouts sometimes. Like it's the oil has been turned to acid, but the compressor didn't run after that burnout event. And you go to cut open a compressor, and then all of a sudden it's really strong. Like you can smell it. There's definitely acid in the system, and you have to stop and take some of these steps, whatever our quote would allow for, whatever we've quoted, to actually make sure we're not going to be out there replacing a warranty compressor in 9 months. Yes, and also installing a suction line dryer. You notice on the suction line dryer there's only a one-way arrow. So I always want to mention to people when you're installing a suction line dryer, it needs to either be inside where the refrigerant is only going to flow in one direction, so between the reversing valve and the compressor, only one direction there, or it's in summer and you know we're going to be back in 10 days, you put it outside on the suction so we can pump down instead of recover the whole refrigerant when we come back. So that process is we install a suction line dryer and it picks up contaminants in the refrigerant over the next week, 10 days, 2 weeks, something like that, and then we come back and we cut it out. And best practice would be actually to just install another one and leave it permanently in the system. And then, but that one that is full of contaminants, possibly other bits of acid that were throughout your system, maybe sitting in a coil, in a low spot in the suction line, things like that, picks it up. So then we take that line dryer out, replace it, leave another one in there, be best practice. That all needs to be thought about when you're quoting that repair, that test, and that way Buddy actually has all the information he needs for sending that quote. Yeah.
How long does the suction line dryer stay in?
Usually 10 days to 2 weeks. And then you replace it with another suction line dryer would be best and just leave it. But if it's a heat pump, you can't just have an external suction line dryer. We were just talking about that. It's only one directional flow. So you could put it inside the condenser permanently and leave it in there once you had replaced that one after 10 days. That's a way you could do it. But we're not leaving any suction line dryer in our suction line because in the winter that suction line turns into a discharge line flowing in the opposite direction that this filter is designed to go. And if it doesn't completely destroy that filter, break it apart and knock it through the system, it will blow out whatever it's caught throughout the years and into the rest of the unit. Airflow considerations. How many times have we quoted a compressor and found things like this on the job,
Yep.
right?
More than once.
More than once. How many times have we gone back to replace a compressor and we did that and we turn it on and things look awful? And we walk through the house and we find stuff like this. Hopefully never, but no, we have. That's why we're having this class, because we can't be replacing a compressor with a coil that looks like this, right? Without addressing that problem. When your compressor goes out, how is it the airflow might have affected the death of that compressor?
Heat
Okay,
stays in the refrigerant.
Higher
Heat.
temperature, higher
so you have the condenser coil here, slam dirty, high temperatures, high pressure, a lot of strain on that compressor. So you should be looking at those coils and making a part of that process cleaning it. When you're replacing that compressor, if you see dirty coils and it hasn't been quoted, you're still going to replace it. You're still going to wash those coils, right? I said replace, I meant wash. I remember replacing a compressor and finding a second filter. So they had one in the nice ceiling spot, and then right under the unit, another hidden filter that was slam dirty. So the compressor had failed, and for years they had replaced just the primary filter. Check for issues with the rest of the system that might have caused that compressor failure. Dirty coils, dirty filters. Also, what are some other things?
For airflow,
Yeah, for airflow that could cause issues. Giving you some hints here.
blower wheel, collapsed ductwork.
Ductwork issues, crappy ductwork issues, right?
Things blocking a return.
Anything that's going to cause low airflow could create a slugging situation. So like if you don't have enough heat on your coil, you don't boil off all the refrigerant. The heat comes from the air. So if you have an airflow issue, then you potentially are not boiling off all the refrigerant through these run times. You combine that with a home where the customer likes to keep things cool in their house. Now we have even less heat to work with. The compressor has these long run times where liquid is making it back into the compressor. And that can cause two problems. It can turn off and the more liquid will kind of migrate and accumulate there, and you have that start where the compressor tries to start and it's just hitting liquid, which can destroy a compressor. Or you could actually have long enough run times where liquid fills up the base of that compressor and gets to the point where the compressor is attempting to compress liquid and liquid doesn't compress well. Liquid will destroy a compressor instantly. So you do have some wiggle room if you have an accumulator or the base of your compressor to fill up with liquid before it actually starts compressing it. But if you have a situation where really poor duct work is contributing, you have systems freezing, things like that, that could be exactly why the last compressor failed. And we need to address the whole problem before we come back, plug in our compressor, turn it on, and we have this crazy low suction pressure and temperature, and now the customer finds out they need to replace the ductwork under the trailer. And maybe that would have influenced the whole decision in the first place with a system, something like that. Those things are really important to know ahead of time.
On the airflow side of things, one other thing to look out for, damper systems. So if you're on a unit that has a damper system, go through and check your zones, check your airflow, make sure it's opening and closing properly. Same thing.
It's good. I erased damper systems and put clog condenser on here.
I would say a thing to remember too, like
That's a very good point.
let's say you have a failed compressor, and you're like, man, their coil looks really bad. I can't quote a coil and a compressor. That would destroy their budget. Who cares? Like they need to know the whole truth.
Yeah, it's very
So
good.
you have to go in and like tell everything you find. Even if you're gonna give them a quote that's like $8,000 and they're never gonna go for it, it's like you're not getting a call back. Could sell a system and leave them better off anyway. So
Yeah, our job is to be a technician and not to actually to worry about their budget and their decision making for their home. We just need to give them all the information that's relevant to that unit and be honest. Yeah, don't shy away from doing your full job. Some refrigerant things to consider when you find a failed compressor. Could be low on charge. How would low on charge contribute to a failed compressor?
Running hot.
Yep.
Requires refrigerant to cool it down.
It's running hot. It requires refrigerant to cool down. Compressors are refrigerant cooled. You run not only hot, but you also have a lot longer run times. How could you maybe find low refrigerant if your compressor's failed and you can't run it?
Standing pressure.
That's right.
Gauge or something and see what it is.
Let's see what it is. But if you don't know what it should be, it doesn't matter what it is.
Based
The-
on temperature.
Mm-hmm. Keep
There's
going.
a slide, refrigerant slider.
Yep. So you need a PT chart, refrigerant slider, and what temperature?
Saturation should be the
Ambient.
ambient.
Yep. Saturation's ambient. That's inside, outside, sort of a combined. But the majority of the temperature that's going to be affecting your refrigerant is outside because that's where most of your refrigerant sits, right? But it's affected a little bit also by inside temperature. If the blower's running and it's 90 degrees inside, it would be slightly higher. But yeah, you usually can just compare it to outdoor ambient temperature, and that's the saturation temperature that you should also have on your refrigerant. Now, if you're just slightly low, you're still going to have a pretty normal saturation temperature. It takes a significantly low system, but it's also a pretty embarrassing miss for a technician who comes back with their compressor and what's the next thing on the list?
Coil leaking.
They weigh out the refrigerant and there's only 3 pounds on a 7-pound system. So that's another thing. When you are actually coming back to do the compressor, weigh the refrigerant out. Because you do need to know before we start this project, before we braze in this brand new compressor, if we're low on refrigerant. So weighing it out. You might be a pound off if you've done a full recovery and the purge cycle and you watch your system and it doesn't really come up after that point. You know you've got all the refrigerant out. But yeah, always weigh out your refrigerant to know what's going on. Doing leak testing. So this is what Matt has brought up several times in this class and he's very passionate about because he's been burnt on before. He's had to do compressors where there was leaking evaporators on the inside. I think we all care about this. But when you are quoting a compressor, typically the age of your system, you should also be going inside and doing a quick electronic leak test on that coil just to see if there's any leaks, at least looking at the history to see, maybe we've replaced the coil, how old is this system, what's been done here, maybe a TXV's been replaced in the past. Is there reason for us to think that there's issues with this system? But yeah, a leak test is a 10-minute thing you can do on an evaporator coil, electronic leak test, before sending a quote for a compressor to save us a complete nightmare on the back end, showing up with a compressor not being able to pull a vacuum because we have a leaking coil, right? We need to be ready to do a full test after we start up our compressor because it could have been a refrigerant flow issue, TXV, something like that, that actually caused the last compressor to fail, and there's not a way to test that beforehand. And those can be difficult conversations, but just stick to the facts. Your compressor was not running, but now that it is running, we see that the TXV probably contributed to its failure, so we got to take care of this now. And that's something we want to take care of same day if possible, as fast as we can, that sort of thing. It can be mentally, it can be very difficult to think about finishing this project and to have that, like, I'm finally done, let's test it out, and boom, there's a problem. That can be one of the hardest things as a technician. But again, that's what we are, we're technicians. Find a way to simulate the best that you can a normal day, and you'll see major problems at a minimum. Okay, electronic issues that take out a compressor. Capacitors and hard starts. Don't quote a compressor if you haven't, and then walk away if it has a hard start kit and a capacitor that you didn't check. Right? How would you check a hard start if the compressor's failed?
Or take their MFD on it.
Yeah, MFD is about all you can do on that. So good practice, hard starts failed, or a compressor's failed, we're replacing the hard start kit with it, the factory hard start kit, right? If it's a factory hard start kit. If it just has some hard start kit on there, we're not putting a new one on with a new compressor. But if from the factory they recommend a hard start kit, then we're replacing it with a factory hard start kit when we're coating the compressor. What else? Electronically.
Pitted contactors.
Pitted contactors.
Stuck.
Yep. You need to be really looking at that and thinking about it. Another good practice is to just replace the contactor when you replace the compressor. But at a minimum, get used to looking at what could have caused that compressor failure. Things like pitted contactors. It can get stuck, melted in place. The compressor runs continuously. Or just that short cycling, voltage drop across it, that all those things take out a compressor. Wire damage. How could wire damage contribute to a failed compressor?
Exposed wires.
It could run all the time like a stuck contactor.
Yep. So you have exposed wires that can create a short where it runs all the time. Or I also have here short cycling. You can have wires that are causing short cycling. Either they're poor connections or the short is happening enough to chatter your contactor.
Bumping the float switch after maintenance while the system's running.
Yep, things that cause short cycling. So if they have a float switch design that pops straight out without a trap and your compressor's failed, often I'll just be dumping water just to be looking in that pan and stuff if maybe the water level's been at the level of that float that would cause that float to be like to have been chattering, causing short cycling for the system.
Inline
Mm-hmm.
float? Okay.
Like an inline or just straight out of the pan.
Yeah.
Yep.
Okay.
Both of those things could cause short cycling and your compressor repeatedly running backwards. All right, school compressor will do that. Not good. Things like this low voltage picture I have here could be this type of stuff that you want to throw in with your quote. Any like improvement things you can do on the system that are going to be long-term really good for this customer. When you're doing something like a compressor, you can add several minor things that completely improve the system and also prevent stuff that maybe you didn't realize that could have caused it. Like this low voltage picture here could have caused chattering, contactor, short cycling, that sort of thing, right? So when you are going to a compressor, when you find a compressor failure, look over your entire system and look for anything else. One other thing, in general, just good practical advice with conversation with the customer. Let them know when you found the reason for failure, and when you haven't found the reason for failure, let them know, like it takes a lot to take out a compressor. Don't really know the story here. I've checked everything I can, but it's possible we have a refrigerant issue. We couldn't know that until we get it running. So letting them be aware of the full situation, that's important. If it's acid, you know what's going on. And they need to have that conversation. Their compressor replacement is going to be a lot more expensive than maybe they've expected or what they Google online, because now we have acid protocol. So having that conversation, it also sets us above competition if they get a second estimate and no one mentions acid, right? We've already mentioned that, we've quoted for it, we have it part of our process. So just be thoughtful with your customer interaction as well. And last but not least, don't force a system sale with compressor failure. We are happy to make money doing a repair if that's the decision that they want to make. And we're good at that. And we're set up to do that well as a company. So make sure you give them their full options.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.